Acceleration. Acceleration is the rate of change of velocity. This means how much faster or slower you're getting. But also, let's remember that velocity is a vector, and so acceleration happens whether it's your speed that's changing or direction that's changing. So acceleration can result from speeding up, slowing down, or turning, changing direction. And the acceleration specifically is how much that speed changes per second. So that means that the acceleration is equal to delta v over t, and this is a vector and this is a vector because we're dealing with velocity, but it's not commonly written that way. It's typically written v2 minus v1 over t. Here we can see that the symbol for acceleration is an a, and the units for acceleration, well, if speed is in meters per second, and then we divide that by seconds again, we get meters per second per second. We don't write that though. We write meters per second squared. When we get to acceleration, we officially can't work with kilometers per hour anymore. We have to move over to the meters per second, or the meters per second squared, and so that's just something to be aware of. Car accelerates from rest to 50 kilometers per hour in 4.3 seconds. Determine the car's average acceleration. So from rest, that would mean initial velocity of 0, to 50 kilometers per hour. There's no direction given in this question, so we can deal with that a couple different ways. We don't have to put anything, or we could assume that we're going to call x, where x is the forward direction of the car. Or we could have put f or something for forward, it doesn't matter. And we have a time of 4.3 seconds. So our acceleration is equal to our change in velocity divided by the time. I nearly forgot here, just as I was talking about a second ago, I can't leave that 50 kilometers an hour alone as it is. I need to change it. I need to change it to meters per second. So, if I recall from a couple videos ago, that means that I have to divide by 3.6, which works out to be 13.9 meters per second, again in this x direction, whatever. So 13.9 meters per second, x minus 0 divided by 4.3 seconds is going to work out to be 3.23 meters per second squared, and whatever we consider to be the positive or forward direction. If our value for acceleration turns out to be negative, what that means is we're slowing down or we're decelerating. But it doesn't necessarily mean that. Recall that at some point we called something a positive direction. So any change that results in the object moving more towards the negative direction would result in a negative acceleration. So we naturally think when we see a negative acceleration that the object is slowing down. And since most of the time we're going to consider our initial direction positive, that's fine, that works. But not always. If we consider our initial direction negative, then a positive acceleration is actually slowing down. Or if we're at rest and we start accelerating in the negative direction, that means we're really starting to go backwards. So let's just deal with the slowing down situation though and see how it results in a negative acceleration. A crate sliding across the floor at 3.4 meters per second slides to rest. That should be width, not wind. I'll just make a quick change there. Oh, actually it's supposed to be in 1.8 seconds. Determine the average acceleration of the crate. So we start at 3.4 meters per second. Go to rest in a time of 1.8 seconds. So what's the acceleration? I'm going to call whatever direction this is the positive x direction, and then we'll see how that works out in the acceleration. So 0 minus 3.4 is just negative 3.4. And 3.4 divided by 1.8, we get an acceleration here of negative 1.9 meters per second squared x. So what that means is the acceleration is negative relative to the direction we've considered to be the positive direction. Since the object was initially going in that positive direction, this is a case where the crate slid to rest or it slowed down over that time. Let's pause here, let's stop this video, and then we'll save the discussions of instantaneous versus average acceleration for the next one.